In this question, we have to determine the voltage VAB. The source voltage is having two components of different frequency, one having a frequency of 1 radians per second and another component having a frequency of 3 radians per second. So in this problem, we are going to treat the source in two cases. One case with one frequency component and the second case with another frequency component, and then we have to find the net current. Okay, first this branch, let us take this as Z1 and this as Z2. Okay, then VAB will be equal to Vs into Z2 by Z1 plus Z2. Okay, where what is Z? Okay, Z is the total resistance. I am going to call Z1 plus Z2 as Z, as a result of which my VAB will be Vs into Z2 by Z. So that is equal to S by 3 due to the inductor plus 3 by S capacitor, plus there is a parallel combination of a inductor and capacitor. So I will get 2S into 2 by S divided by 2S plus 2 by S. Okay, so this on simplification becomes S power 4 plus 16S square plus 9 divided by 3S into S square plus 1. So this is the total impedance of the this branch and this branch. So I am going to substitute S equal to J omega, because I have to find the response of the system for two different frequencies. Okay, so Z of J omega will be equal to omega power 4 minus 16 omega square plus 9 divided by 3j omega to 1 minus omega square. Also Z2 is equal to 2j omega by 1 minus omega square. Okay, now at omega equal to 1, okay, that is corresponding to one component which is having a frequency of 1. In that case, VAB1 will be equal to BS1 into Z2 by Z. Okay, this holds good for either cases with the two different frequencies also, and even this expression 240 into, okay, Z 2 omega by, this is Z2, okay, 2 omega by 1 minus omega square, okay, into 1 by Z. Okay, so that is magnitude of 1 minus omega square into 3 omega divided by magnitude of omega power 4 minus 16 omega square plus 9. Okay, this at omega equal to 1. So when I determine that, I will get 240 volts. Similarly, at omega equal to 3, I will get VAB 2 is equal to 70 volts. Okay, for this component you have to take VS1 accordingly. Okay, so VAB is equal to, since it is the RMS, it is root of sum of the individual components squared plus VAB2 squared. So that is equal to 250 volts.